So in this lesson, we're going to be talking about gas mixtures and partial pressures. So the really cool thing about gases is encompassed in Dalton's law of partial pressures. Specifically, if you have a bunch of gases, you can actually take all of their partial pressures and sum them together to find the total pressure of that gas sample. So the formula for this is P total, the total pressure, equals the sum of all the partial pressures of the gases that exist in the sample. Another way of determining this is to use mole fractions in determining partial pressures. So here's the equation right here. The partial pressure of one gas equals the mole fraction of that gas, specifically the number of moles of that one gas, divided by the total number of moles of the gas, times the total pressure. And it's actually quite easy to determine the total number of moles of a gas. You simply add up the moles. So gases work really nicely because you can simply add their pressures or add their number of moles together. So for this problem, there are two different gases that are given to you, and it's asking for the partial pressure of each gas and then the total pressure. Now there are two different ways of completing this problem. I'm going to do it one way. The other way you could do it, you're going to be using the ideal gas law no matter what. And so what you could do is you could solve for the partial pressure of each first by simply taking the two gases, converting each of these into moles, and then solving for P. And then you just add them together to get the total pressure. That's one option. I actually like the other option a little bit better simply because it shows just how versatile gases are with respect to comparing them and combining them together. And so what I'm going to do here, just like what you would do for the previous way of doing the problem, I'm going to take the mass of oxygen and I'm going to first convert that into moles because I need to know the number of moles. Okay, so the molar mass of O2 is 32. And so what I end up getting for this is 0.1875 moles. Okay. And so yeah, this would round to 0.19, but I'm not going to round until the very end. And then I'm going to have 9.0 grams. And this is of methane, and the molar mass of methane is about 16.05 grams. And so the number of moles here would be 0.5607 moles. Okay, so if you want to, you can just take each of these, plug them into PV equals nRT, your ideal gas law equation, and then calculate the pressure for each of them. What I'm going to do instead, just to show you how versatile gases are, what I can actually do with these two numbers of moles, I can just add them together. And so if I add them together, the total number of moles would be 0.7482 moles. And so what I'm going to do right now, I'm going to plug that into my ideal gas equation to solve for pressure. So pressure times my volume, which is 15.0 liters, equals my total number of moles, which is 0.7482, times my R, which is 0.0821, times my temperature in Kelvin, which is 273. And so my total pressure, my P total, is going to be 1.12 atmospheres. Okay? And just to use the concepts that I introduced just a second ago, I'm actually going to take this total pressure and I'm going to find each individual partial pressure by using the mole fraction. So if I have the pressure of O2, its mole fraction is going to be the number of moles of just oxygen, which is 0.1875, divided by the total number of moles, which is 0.7482. So the mole fraction times the total pressure, which is 1.12. And so what I get for the partial pressure of oxygen is 0.281 atmospheres. For the partial pressure of methane, I'm going to do the same thing, but use its mole fraction, which is going to be 0.5607 divided by the total number of moles, which is the same, times the total pressure, 1.12. And what I end up getting for the partial pressure of CH4 is 0.839 atmospheres. Okay. Now, if I'm going to be rounding properly, all of these values up here should have been just two significant figures, and so as a result, I should take these answers, and instead of 0.281, it should be 0.28 atmospheres because I waited to round until the very end, and 0.84 atmospheres. Okay? Notice if I add these two together, I get my total pressure. Now if you did it the other way, where you just took each of these moles and plugged them in and got the individual pressures and then added them together, it still will work.